This is Mr. Martin. These are video notes for Unit 1. We're going to be talking about logs today, just an introduction to logs. Some of this you may know. So our learning targets today are to be able to rewrite a logarithm as an exponent, as an exponential, and to be able to do the opposite, and also to evaluate a logarithm. So when we talk about a logarithm is basically an exponent. It's a different way to write an exponent. So for example, 5 to the first is 5, or 5 to the second is equal to 25, and we could also have something like 5 to the x is equal to 200. These are logarithms. They're just written in exponential form. So we're going to learn how to write these also in logarithmic form. So here's our two different forms. We've got our logarithmic form on the left and our exponential form on the right. And let's take a look at the different parts here. I've got this a here, which is a subscript. This is our base. And then I've got my b over here, and this is my exponent. And then my c over here, this is my output. And sometimes we'll just refer to that as the answer. Okay, so if we go over to the other form, the exponential form, again, let's label each part. This is the base, and b is the exponent, and then c is our output, or again, our answer. So a note over here, when we're in logarithmic form, note, if there is no base written, we assume it is 10. Because usually if the base is 10, we just leave it off. Okay, so let's take a look at rewriting. We've got a few examples here going back and forth. So when we're going from logarithmic form to exponential form, I know some teachers like to teach this around the world technique. So we start here at the base, and we go around this way, and then around this way. So then if we're going to write this in exponential form, we would have 5 is our base, 0 is our exponent, and 1 is our output. Alright, and then if we're going the other way around, so our base is 10 over here, so I'm going to have the log base 10, and our output is 0.1, so log base 10 of 0.1, and that's going to equal our output, which is over here. Hang on a second, sorry. So we have the log base 10, here's our base, of no, I was right before. 0.1 is equal to -1. I'm sorry about that. Because then we can check if we go, we're going to go this way, so 10 to the -1, which matches up with this, and then equals 1.0. Okay, moving on to the next one. Sometimes you'll have the log on the other side. If you just wanted to rewrite it as the log base 3 of 1/27 is equal to -3, and then we could start here at our base and go around this way. So we would have 3 to the negative 3 is equal to 1/27. Alright, and then over here, my base is 5, so I'm going to have the log base 5 of x is equal to 3. Again, if you wanted to check, you could just, double check. If we go around the world here, we're going to have 5 to the third is equal to x. Alright, and then our last, second to last one here, again, if you want to rewrite it as the log base 10 of x plus 5 is equal to 2. Then we start here at our base and go around. So we had 10 squared is equal to x plus 5. And then our last one, again, our base here is a. So it's going to be the log base a of c is equal to b. Log base a of c is equal to b. Alright, and after you do a bunch of problems converting between forms, you'll get the hang of it. And make sure you get help when you need it. As always, if you have questions, make sure you pause the video and write those questions down so you don't forget to ask me the next time you see me. Okay, so we can rewrite logarithms as exponentials as a way to evaluate logarithmic expressions. So if we're trying to evaluate these expressions here, we're going to do the ones on the left, and then you can try the ones on the right, and we'll check those in class. So for part A, typically what I like to do is I like to assign this a variable. Typically I'll just call it x. So log base 4 of 64 is going to be some value x. And then we're going to rewrite this in exponent form. So I would have 4 to the x is equal to 64. So what you want to think is 4 to what power equals 64. Okay, so if you want to work it out a little bit by trial and error, you can. But 4 to the third is going to be 64, which means that x is equal to 3. Okay, if you want to pause the video and try and do part B, otherwise we can work through these 3 examples on the left, and then you can pause the video and work through the 3 examples on the right. Alright, so next problem, again, I'm going to set this equal to x, and then I'm going to rewrite it in logarithmic form. So I have 1/5 raised to the x is equal to 125. So in order to get 125 from 1/5, I'm going to have to change this exponent to something that's negative. So if it was 1/5 to the third, it would be 1 over 125. So if I change x to negative 3, then it's going to be, we take the reciprocal. Remember, negative exponents, you have a reciprocal, and x is going to be negative 3. Alright, if you have questions about negative exponents, make sure that you ask me. Alright, part E, again, set that equal to x. We can rewrite it in exponential form. So I have 8 to the x is equal to 0.125. Sometimes I find it easier to do these as fractions, so we want to change this to a fraction. You can do that on your calculator also. Just type in 0.125, hit the math key, hit number 1, hit enter, and it will tell you that this is 1/8. So I know that 8 to the first is equal to 8, so that means that 8 to the negative first would be 1/8, so x is going to be negative 1. Okay, if you want to pause the video and go ahead and work out the problems on the right, that would be a good idea. If you want to check your answers, I'll just put the answers here so you can check as you go through to see if you got them. So for part B, x is going to be -1. For part D, x is going to be 1/2. And again, you should make sure that you can work through these. And for part F, x is going to be 4. So if you have questions about any of those three, make sure that you ask me. Okay, moving on. By the definition of a logarithm, it follows that the logarithmic function g of x equals the log base b of x is the inverse of the exponential function f of x equals b to the x. That means that if we do the composition of g of f of x, so that would be the log base b of b of x, this log base b and that base there are going to cancel out, so we're left with x, which is what we should get if we do the composition of inverses. Or if we do f of g of x, we're going to have b raised to the log base b of x. These are going to cancel out also, the base and the log base b, so that's going to be x, so they undo each other. Alright, so let's move on to some more examples here. So we want to simplify each expression. So for part G, there's no base here, so we know that it has to be 10. So I'm just going to rewrite it as 10 raised to the log base 10 of 4. And we know that this base of 10 and that log with a base of 10 cancel each other out. They're inverses. So this is going to equal 4. And for part H, I have log base 5 of 25 to the x. So again, I'm going to rewrite this a little bit. This is going to be the log base 5, and I know that 25 is 5 squared. And then I also had an x up there. The x is there. So this 25 is 5 squared. And then I have a log base 5, and I also have a base 5 here. So these are going to cancel each other out. And we're left with 2x. Moving down to part I. Again, I have 10 raised to the log base 10 of x minus 5. So that 10 and that log base 10 cancel, and I'm left with x minus 5. And then over here we have a natural log. So a natural log is the same as log base e. So with a log base 10, the log base 10 and the base of 10 cancel each other out. For a natural log, the natural log and the base of e cancel each other out. So basically what I have here, we can rewrite this as the log base e, so the natural log is the log base e, of e to the p plus 3, and then these cancel each other out, and we're left with p plus 3. So again, if you had any questions, make sure you write those down and ask. I'm going to end the video here, and I'm going to have a second video with a couple of the next examples worked out for finding the inverse of each, and then I'll leave a few for you to work out, and you can ask me questions if you have those in class, or check your answers when I see you in class.